the next question, right, that we can answer. So these are, right, the 5 steps. And what you have to remember about the scientific method is if your conclusion is not always going to answer your question, right? It might be inconclusive or it might provide more questions. Well, shoot, Jimmy, I don't have a way to get Jimmy John's. Okay, what else am I going to have for dinner? And so this is really a cycle, right? It can be a cycle that comes all the way back, right, to maybe I need more observations. Maybe I need to do ask another hypothesis, ask another question. Maybe instead of Jimmy John's, no one's available to go there. Maybe I know my dad is coming home from work, and so what's on his way home from work? Oh, he's gonna pass a McDonald's. I don't know. Things like that. Okay? It is a cycle. It is not just a one-time thing. You sometimes, especially in science, right, in chemistry, lots of times your problem or your question isn't answered by one experiment. And it's not really valid if it's only one experiment. Somebody else has to do it too and say, oh yeah, I got the same conclusion. Okay? It has to be backed up in science by more than one person, more than one experiment, in order for it to become really something that everybody understands and everybody accepts. The last thing that we're going to cover is what are parts of an experiment. And again, I would say that this is much more for science, right? Like I said, if I run an experiment and I say, oh my gosh, water is a solid, I proved it, right? Someone's going to come and be like, wait, right? Let me run your experiment and let me see if I get the same results. And so an experiment needs to have certain parameters, meaning certain guidelines and boundaries, so that somebody can repeat it. Okay? So number 1, obviously the first thing is you need a problem. Oops, I got the wrong marker again. I got the one that's about to run out. Let me rewrite this. A problem and a hypothesis, right? You've already got your question and you have your prediction, what you think is going to happen, okay? The second thing that is part of an experiment are the variables and the constants. Okay, the variables are going to be what changes. Okay, variables are what changes. And there's actually 2 variables. The first variable is called the independent variable. The independent variable is the one that the scientists change. The one the scientist changes. Right? That might be where you go eat or who you call or something like that, right? Then there's the dependent variable. Right? And the dependent variable is what results from the changes you make, from the changes made by the scientist. okay, the independent and the dependent variable. Then there's these things called constants. What is kept the same? That's what constant means, right? What is kept the same? Okay, this means, right, that you are only testing one thing and keeping everything else the same. For example, if I'm testing the temperature, right, of maybe this beaker of water, right, and I am putting one ice cube in and seeing that temperature. If I put 2 ice cubes in, right, I'm changing something that I don't want to change, right? Or if I change the amount of water in that beaker, I'm changing something that should really be constant, right? Like I might make a hypothesis like, oh, 1 ice cube will bring it below 10 degrees Celsius or something like that, right? So I'm going to test that. But if I put 2 in, or if I put less water in, right, I'm going to have to try and make sure that I am controlling or keeping some things constant so that I can repeat the experiment, okay? So that the experiment isn't contaminated almost, right? Like, in the sense that, like, I can only attribute it to that ice cube, right? I can't say like, well, it's because, you know, the water was different, or the beaker was different, or the ice cubes were not the same size, that kind of thing, okay? Then the next part of an experiment is called the control. I should say the controlled and experimental group. The controlled and experimental group are your 2 groups, right? The controlled group is going to be sort of what's normal. Or what the results are compared to. The experimental group is, right, the group that has the changes made, or the change done. You'll see in your homework what we mean by that, okay? For the procedure, obviously, right, you need some sort of list and description of how you're going to run your experiment. And what you have to remember about your procedure is it's usually steps, right? Usually steps, numbered steps. And it must be clear and repeatable. Remember, like I said, in the scientific community, right, somebody else has to be able to repeat my experiment, right, and get my same results. If they don't get my same results, then my experiment may not be valid. The last thing, obviously, number 5, is data. Okay, and there's 2 types of data. They both start with Q's. There are 2 types of data. There is Quantitative data, that's easy. Quantitative, meaning quantity, is numbers and measurements. Qualitative data is a description, the quality of something, the color, warm, fuzzy, that kind of thing, okay? You will get some practice on this in your worksheets.